Hello everyone and welcome back to our Python data science workshop. I'm Chi and it's so good to see you here. In today's session, we'll be talking about Matplotlib to get an idea about data visualization in Python. So as you can see in this figure, these are many small subplots that are made within Python. So Python is actually a very strong tool for data visualization. And in Python, there are several options for data visualization. But Matplotlib stands as the fundamental plotting library. In the history of Python language, Matplotlib was actually the first plotting library for Python. It is designed to be similar to Matplotlib, so this will make it a bit different from the typical Python syntax, and we will know this in the later session. But it gives us a powerful control over our visualizations. And in this tutorial, we'll first start with the basics of creating plots and understand how to customize them. And then gradually we'll work our way up to creating more professional quality visualizations. So first, let's start with the basic of Matplotlib. So first, to use Matplotlib, we need to import its pyplot module. And the standard import statement, as you can see here, is import matplotlib.pyplot as plt. So breaking this down, matplotlib is our library, and the .pyplot is the specific module we will use for plotting, and plt is just a shorter name we give it, because this will save us from typing the full name each time. So for our plot to work, we will typically also import numpy and pandas. These two are good friends with Matplotlib. Once you have import the necessary libraries, now let's try to understand how a Matplotlib plot is structured. In short, every plot has two main components, as you can see in this figure. The first is figure, and the second is the axis. So as you can see, the outer box is the figure. We can understand figure as a container, or you can think of this as a canvas where you're gonna draw the plot. It is the entire window where you plot lefts. And inside the figure, we have the axis, which is where the actual plotting happens. This is where you will see your data, the tick marks, and labels. And as you can see here, the axis contains elements like axis labels, also the tick marks, and the plotting areas itself. And the major ticks are the main division on your axis, while the minor ticks provides finer gradations. And we'll work on these components throughout the session as we build up different types of plot. But first, let's start with the basic plotting. So Matplotlib provides two main functions for basic plotting. First is use the plt.plot for line plots, and then plt.scatter for scatter plots. And for this example, we'll create a line plot using very simple math, so sine and cosine waves. First, we'll generate our data using numpy. So this code will generate an array of 100 points between -5 and 5 for our x-axis. And then we're going to calculate the sine and cosine values for these points. So as you can see, we have the y sine and also y cosine. So after run this code, we can plot the sine wave and also the cosine wave. And as you can see here, when we use the plt.plot function, both the lines appears on the same figure. And this is something important to note, because Matplotlib will continue adding to the same figure unless we explicitly create a new one. And as you can see in our output, we indeed got two waves, the sine wave, the blue, and also the cosine wave in orange. And this is just a simple example of how you can create and combine multiple plots. But often in practice, you may want to separate the graphics instead of overlapping ones. To do so, you will need to create a new figure instance. And this is done using the plot.figure function. So to create separate plots, we should first assign each figure to a variable. So here we're creating figure 1, which is a single plot, a single figure, and then fig 2, which is another figure. And then this will create two independent windows. So one will be used for the sine wave and another for the cosine wave. And storing these in variable is useful when you need to modify the plots later. And now, if we look at the plots, we can see that indeed the sine wave and also the cosine wave are plotted in two different figures. And now let's take a look at scatter plots using the plot.scatter function. And so instead of connected lines, scatter plots show individual data points. Here we're using the same sine function but with fewer points for better clarity. So here we have 25 points. And if we run this code, because now we're using the plot.scatter function, we can see that in this scatter plot, it shows distinct points rather than a continuous line. And this is particularly useful when you want to emphasize individual data points rather than the overall trend. So we just did our very first basic plotting, both the line plot and also the scatter plot. Now, let's talk about keywords argument in Matplotlib. So in addition to the required x and y parameters, we can also use optional keywords argument to customize how our plot looks. And the most commonly used ones are colors, marker, and line style. And then in the next few minutes, we're gonna walk through each one of these. So let's first focus on colors. Matplotlib actually gives us several ways to specify colors in our plots. And as you can see here, the first method is to use the HTML/CSS names. So you can use names like dark blue or green, and in total there are 140 named colors available, and they're very readable in your code. So here, this graph has all the colors that you can use for using the HTML names. And even for some basic colors, you can use the single letter shortcuts. So for example, R for red, G for green, B for blue, and so on. And this is particularly useful when you want to do some quick plotting. But sometimes you may want to have more precise control. The second method for defining the colors is to use the RGB values as tuples between 0 and 1. So for example, here we have 0.2, 0.7, and 1. This will create a blue-green color, and adding a force value would also control the transparency. However, you can also use grayscale values between 0 and 1, where 0 is completely black and 1 is white. So for example, 0.5 will give us a dark gray. And finally, for the most flexibility, you can use the hex code. In this case, we have C6E2FF, and this is common in web design and give you access to any possible colors that you want to use. So, for example, sometimes you want to use a specific color plate, and then you can use the hex code in this case. And now let's see this in an example. So here we're creating an empty figure, and we're creating different sine waves with different colors. So we have the dark blue, we have the short letter code, and also we have the RGB method, grayscale, and then finally using the hex code. And then now you can see this plot looks very colorful. So we successfully plot the sine waves in different colors using different methods to specify the color. And feel free to play around with this by modifying the code. And secondly, about line styles. This is also a very useful keyword argument, which will let you change how your lines appears in the plot. And by default, Matplotlib uses a solid line, but you have several other options to choose from. In this table, you can see the main line styles. They are solid, dashed, dotted, and dash dot. And each of these can be specified in two ways. So either you can use their full name, like solid or dash, or you can use the shortcut. For example, here we have two dashed for dashed lines. And in our example here, we're combining different colors and line styles for 5 sine waves again. And this will show you how actually you can use multiple keywords argument together to create distinct and easily distinguishable lines in your plot. So for instance, so here we have a dark blue dashed line, and also we have a magenta dashed line, and then we have a dotted cyan line, so and so on. And finally, let's look at markers. This will let you highlight individual data points in your plot. And markers can be used in both plot.plot function and also the scatter function, but they behave slightly differently. And Matplotlib also provides several marker styles conveniently. And you can see here in this table, we have circle, we have point, we also have stars, plus. One important thing to note is that unlike color and line style, markers only accept the shortcodes. So you cannot use the full name like circle or stars. You have to use the marker code for this in this case. And here, if we run this code example again, what we see is that we can see multiple sine waves and plotted in dots. And here is because we're using the scatter function, so we see the individual points in different marker styles in different colors. But if you use the traditional plot function, you will get a line connecting your points with markers at each data point. So they look slightly different. And you can choose depend on how you want your data to be visualized. And up to now, we have used explicit definitions to specify the keywords argument. So, for example, before in this case, we always put, for example, color equal to, and also markers equal to, and this called explicit definition. Well, this is generally preferable, but Matplotlib do allow an easy way to combine color, line style, and markers into a single non-keyword argument. So for example, if you want to plot a dashed red line, you can specify it as R. We're using the shortcut for red color, and then the double dash for the dashed line. And here you can see that, again, we're using the shortcut to specify different styles of the line plot. But one thing to note is that the downside of this method is that you are limited to 8 colors that have the single letter code. And if you want to use other colors, again, you need to explicitly define the keywords arguments. And except this, there are tons of other keywords argument that you can explore. For example, there are line width and also the marker size and also even the transparency. And if you want to dive into this, you can click this hyperlink. And I would highly encourage you to explore this, because sometimes we would often want a more refined, nifty plot for a specific purpose. Okay, moving on. Now let's look at how to customize the axis of our plot. So while Matplotlib usually does a good job with default settings, sometimes we do need more control over how our axis look. And first, we can set the limits of our axis using the plot xlim and plot.ylim functions. And these functions controls how much of the data is visible in our plot. For example, in this case, the plot.xlim minus 50, 50 will set the x-axis to show values only between the range of minus 50 to 50, and so does for the y limit. And this is particularly useful when you want to focus on a specific range of your data. And we can see here, our y sign is only limited from minus 5 to 5. And we can see that now it's looks very tiny in the middle. Well, the other thing is that we can also control the tick marks and their labels. So the plot.xticks and plot.yticks functions let us specify where we want tick markers to appear and how they should be labeled. So the function xticks and yticks method will allow us to control the location for both the ticks as well as the labels on the y and x axis. And both methods accept toList or array-like arguments, as well as optional keywords argument. And the first one will correspond to the ticks, and then the second one will correspond to the tick labels. So here, for example, we're setting an we're setting the x-axis tick starting at 0 until 1 and increment it by 0.25. And if you don't want all the tick markers to be labeled, you can pass a string list. And here, in this example, we're only showing 0, 20, 40, 60, 80, and 100. And if we run this example code, we can see that here we set the x ticks label starting from -4 to 4, and only -4, -2, 0, 2, 4 are labeled. And as well, we specify the tick labels for the y-axis. And as with any plot, you don't want to not include the x and y-axis label, and this can be done by passing the string to the plot.x label and plot.y label. And here you can see that by set the axis label, now we have the x-axis label and also the y-axis label. And another nice feature about Matplotlib is that it supports the TX formatting for mathematical expressions, and this is quite useful for displaying equations, formulas, or exponents or units. And here we can use the math expression to denote our x and y labels. So the way to do here is to use this function. You can see that we starting with the $x, and then you just put the expression within the dollar symbol, and then whatever inside the dollar markers will be formatted using the mathematical expression. And now we can see that the x now is italic, and so we can see that it is indeed be formatted differently. So adding a title to your plot is also very similar to labeling the x and y axis. And the only thing that is that you need to use the plot.title function to add the title, which will be on top of your figure by default. So here, by adding the final line, we can see that now we have a title in our figures. And when multiple datasets are plotted on the same axis, it is very useful to include a legend that labels each line or set of points. And actually, Matplotlib has a quick way of displaying a legend using the plot.legend function. And there are multiple ways of specifying the label of each dataset. First, for example, you can pass a list of strings to the plot legend. So here, we're passing a list of label strings called sin x and cosine x. And if we run this code, but first notice that first there is an order because we first plot the sine wave and then the cosine wave. So the sine wave will be denoted and then followed by the cosine wave. And another way of setting the data label is to use the label keyword argument in the plot function method. And this will already set up the label name for each variable. And then in the end, you just need to use the plot legend function, and the label will be printed in the legend framework. And as you can see, we have sin x and also cosine x. So the above keywords argument are just part of the picture of what Matplotlib can do. And again, there are tons of other keywords arguments. But the important thing is to know that having this level of control is particularly useful when you are creating plots for specific purposes. Now, so far we have touched some of the basics of plotting in Matplotlib. Now let's get a bit more complicated. First, let's look at creating multiple plots in a single figure using subplot. So oftentimes you may want to plot data on multiple axes within the same figure, and Matplotlib lets you arrange them in a grid format. The easiest way to do this is to use the plot.subplot function, which will take three arguments. First, the number of rows, second, the number of columns, and then the index position. So for example, in this picture here, if you want to create 2 by 3 grid, 2 rows, 3 columns, Each subplot will be referenced with the numbers from 1 to 6, counting from left to right, top to bottom, as shown in this figure. And the important thing to know here is that the index here actually starts as 1, not 0, as commonly what we saw in Python. So there is some slightly inconsistency, and it's always to be mindful of this. And here is an example of, again, one row, 4 columns, and again, it's starting from 1 all the way until 4. A more explicit way to create subplots is to using the fig.add subplot function. So after creating a figure with plot.figure, you can add individual subplots and store them in variables. For example, here axis 1 equals to the first plot, and then axis 2, and so on. And if we run this code here, we can see that indeed we have 4 of our axes, 1, 2, 3, 4. And when working with the subplots, if you want to plot something on the subplot, instead of using the common plt.plot function, now we need to use the x.plot on the specific subplot where we want to draw. And this will give us more control on each individual plot. And each subplot has its own axis object that we can customize independently. So here in this example, again, we first initialize an empty figure, and then we add 4 axes from 1 to 4. And then for each axis, we use the plot function or scatter function to plot on each individual axis. And if we run this code, we can see that indeed for the first plot, we have the sine wave in dark blue color and in circle markers. And then for the second one, we have again the sine wave, but in magenta color and in triangle color, and so on. So now you may be a bit confused because we have figures, but we also have axes, and this is quite tricky. So when working with subplots, we need to understand the difference between figure and axis method. So while many comments are similar between the plot and x function, there are some important differences in how we use them. So for most of the basic plotting commands, from figure to axis, we have a direct translation. So for example, plot.plot will be x.plot, and plot.legend will also be x.legend. But then when it comes to controlling axis settings, the syntax change a bit. So for example, if we're setting the x-axis label or y-axis label in figure command, it will be plot.x label, but then in axis command, it use x.set x label, x.set y label, and so on for the limits and also the ticks. So the difference exists because the plot commands come from MATLAB's legacy, while the X commands follow Python's object-oriented style. And usually the arguments work the same way in both cases. It's just a matter of different syntax. So if we look at the last example, here again we're creating, first initializing an empty figure, and then we add our 4 axes. And we're also plotting the data as we did before. And now we're writing a for loop to go through each of the axes and specifically set using the x command to set the x limit, the title, and also here we're adding a condition to only label the x-ticks and x-axis on the bottom row, and same for the y-ticks. And in the end, we add a tile layout function which will automatically format the figure to fit the window. And now if we run this code, we can see that indeed now compared to the figure before, Now we have the y and x axis removed for the right columns, and we have also add the label for x and y. So we have more control using the x method. And again, here we're using the plot.typeLayout function. And this is pretty useful when we are in an integrated development environment. If we have a separate plotting window, rather than with inline plots here, like using a notebook. And if we want to have a sense of how what changed this make, you can see that it's slightly shrinked. And but if we put it back, we can see that now it fits to the size of the window in our notebook. And now I would encourage you to pause data and try to do some little exercise. So you want to make two lists of 10 numbers, and then let's try to make a two-panel plot. So we have two axes, x1 and x2, to do a scatter plot and also a line plot. So now let's try to work with some real-world data and get a sense of how to use in Matplotlib to do different types of plot rather than just basic line plotting. So again, here we're using our Ghana DHS household filtered survey dataset. And first, let's import the data frame. And the first thing we want to do is to check how our data set looks like. So first, let's use the head function to print the first 4 rows here. And as we can see, here we have the different clusters, the country, and also some key variables related to public health. For example, stunting, wasting, BMI, and also wealth index, as well as we have their latitude and longitude. But for this, we're not gonna do a geospatial plotting, but for now, we'll just do a very statistic plotting. So first, we can check the shape of our data frame, and we can see that we have in total around 6,700 observation. And before we do any exploratory analysis, one key thing to know, and this is super common in dealing with when working with real-world data, is that we typically will have a lot of non-value or missing values. And now indeed, we see that we have nearly half of our data sets has some non-values. And as you can see that our data size is organized in a way that stores household member, which is basically each kid given by the mother from the household. And all the metrics are individual or household level. And now before doing the plotting, we can quickly check some very simple statistic. So first, we can check what household has the lowest height for age as a z-score. And we can see that it also happens to be in the poor on the wealth index domain. And also we can see print which household has the lowest weight for age score. And actually, we could also subset on our survey to see that how many of them are from the rural areas. And as again, using pandas, we can even create a new column which is derived from the height and weight ratio. And as we can see that here we get a warning, and this is because we are doing it directly on the df.rural instead of creating a copy before. And if we create a copy, we can see that the warning is gone. And just to make yourself a bit familiar with what we talked about before, what is view and what is a copy. So now finally, let's try to do some exploratory data analysis and visualization. And here we made this tutorial in a way to first show you some classic types of plot that we usually do for data analysis. And the first one is a histogram. So a histogram is a type of graph that show the distribution of numerical data by dividing the data into different bins or intervals. And each bin will represent a range of data, and the height of the bar reflects the number of observations within that range. And so histograms are quite useful if you want to get a quick sense of the density of the data, basically the distribution, and also the central tendency, if it is skewed or not. And here in this example, we are using the plot.hist function to plot the height, the new variables that we just created. So it's the height for age function. And here we can see that it looks like a normal distribution in this case, but we can see that in average, the height for age is a bit under 0, which means that actually a lot of these surveyed households are under nutrition because the height is not the height level, because the average height level is below their age range. And secondly, the bar plot. So a bar chart actually use bars to show comparison between categoricals of data. And the height or length of each bar is proportional to the value it represents, which make it very useful when we want to compare different groups. And here, in this example, we're using our bar chart to visualize the average stunting rate across rural and urban household. So to do that, we use the plot.bar function. And before that, we'll first group the stunting rate by the rural or urban columns, and then we took the mean of it. And if we run this code, we can see that on average, the stunting rate on rural household is higher than urban areas. And the third one is a box plot or box and whisker plot. And box plot is a standardized way of displaying the distribution of data based on a 5-number summary. So we have the minimum, the first quartile, median, third quartile, and maximum. And it's visually summarized several key aspects of a dataset distribution, including the central tendency, variability, skewness, and the presence of outliers. And although Matplotlib has the built-in function of doing a box plot, here we are showing you how we can use Seaborn to create a box plot. So Seaborn is another very popular and important Python data visualization library, which is actually built on Matplotlib and integrates closely with Pandas data structure. It's more higher level, so it simplifies the process of creating complex visualization, for example, heat map, violin plots, and many others. So here, the function is the sns.boxplot, and we're actually trying to plot the distribution of the BMI index across different wealth index groups. So we have the wealth order from the poorest to the richest, and then we're gonna see how the BMI distribution is across the different wealth index group. And as we can see that the BMI actually increased, we can see a tendency of increasing from the poorest group to the richest group of the BMI. And similarly, we can also visualize the height for age. So similarly, we can also visualize the height for age variables across different wealth group. And although this is less obvious, but we can still see that from the poor to the rich, we can see the increase of the height to age z-score. And now about pie chart. So pie chart is actually very straightforward. It is widely used to represent the proportion or percentage of each category compared to the total. And they're very useful when you want to highlight proportional within a single categorical variables. And they're best to use when there are not too many categories to keep the chart readable. So in this case, we're trying to visualize the proportion of different wealth group within the wealth index. And we can see that out of all the surveyed household, the largest proportion is the poorest, followed by poor. And not surprising, the richest has the lowest population in our survey. And finally, scatter plot. So a scatter plot is a type of data visualization that uses dots to represent the value obtained for two different variables. So one plotted along the x-axis and the other plotted on the y-axis. They're very useful if you want to observe any kind of a relationship between the variables. So to use that, we can use the plot.scatter function. Here, we're trying to plot a scatter plot of the height for each z-score and also the weight for each z-score. And if we see this, we can see that the weight and height, they look highly correlated from this scatter plot. And you can even add more complexity to your plot. So in this example, so instead of just visualizing all the point, so compared to the previous figure in our new output, now we have also the urban and the rural classes that are plotted on the scatter plot. And we did this by first subset our data frame of only the urban dots and plot that, and then we subset the rural dots, and we also add legend to make it more distinct. And finally, you can also try to replicate this for visualizing other variables. So here, instead of urban versus rural, we plot the height and weight across different wealth index group. So we're comparing the poorest to the richest. And as we can see that the blue dots are the richest household, and we can see that their distribution is more upward towards the diagonal, which means that by just roughly guessing, the mean of the weight and height to HZ score could be higher than the poorest household, which actually corresponds to our scatter plot before. Sorry, to our box plot before. And now, after all this visualizations, I want you to pause the video and then try to finish this exercise on your own and try to modify the code and create different types of plot for explanatory data visualization.